Good day everyone. I am here to tackle about the definition of scaling. So what is scaling? Scaling, it is a device used for measuring various things. It is an extension of measurement. It explains the procedure of assigning numbers to various degrees of opinion, attitude, and other concepts. So, ang kanilang scaling is nag-explain siya sa procedures of assigning numbers to a various degrees, and also it kanang ang scaling kay it is an extension of measurement. So mao na siya ang scaling. Mechanical scale. So under the mechanical scale is reduced scale. So what is reduced scale? Reduced scale is when a drawing is made smaller than the actual object typically used for very large items like buildings, ships, and maps. It is expressed a ratio where the number on the left is smaller than the number on the right. So, ang kanilang mechanical scale is typically used for very large item like sa building, sa mga ships, or sa other like sa maps. So, ang kaning reduced scale, it express a ratio where the number sa left is smaller than the number on the right. So, I have here an example. Example, scale 1 to 50, meaning 1 unit on the drawing represents 50 of the same units in real life. So, muna siya ang example. How reduced scale works. So, proportional reduction, the object dimensions are proportionally reduced to fit on a smaller medium like a sheet of paper. So, ang kaning reduced scale kay nasa proportional reduction, which is ang pag-reduce niya is dapat ma-fit siya on a smaller medium like a sheet of paper. Next is representative fraction or RF. A reducing scale has a representative fraction that is less than 1. The RF is calculated as the ratio of the drawing distance to the actual object's distance, using the same units for both. So, here is the example. A 1 to 2 scale means that every 1 unit on the drawing represents 2 units in real life. The drawing is half the actual size. So for example, kanang mag-drawing ka og square in a bond paper. So every unit on the drawing or sa imong gidrawing nga square is represents 2 units in real life. But the drawing is half in the actual size. So mo na siya sa representative fraction. So next, let's talk about the common uses of reduced scale. So first is architecture. Blueprints for multi-storied buildings, large structures, and other architectural plans. So ang kaning architecture is, of course, ang mga architecture is mag-use sila og blueprints para ang ilahang kanang gidraft nga drawing is the same scale sila ang gigamit para ligon or para makita nila kung ligon ba ang pagbuhat sa kana nga buildings. And next is engineering. So creating drawings for large machinery, boilers, and bridge. So ang kaning mga engineer is mag-create sila og drawings for large machinery, boilers, and bridges. So ang kaning engineer is mag-draft ni sila og drawing nila in order for them para mabalaan nila kung maayo ba or kanang kuan ang ilahang pagtrabaho sa kana nga proyekto nga ilahang trabahoon. And last is the cartography. So creating maps to represent large geographical areas on a smaller surface. So ang kaning cartography is mo ni sila mag-create og maps para represent kung kanang magkuha ni sila kung asa dapit ibutang ang kanang ang pultahan, or asa dapit ibutang ang kanang bintana, or kanang ang mga buildings ilabang kanang kanang punan ba nila kung asa dapit kanang kuan, para in order for them nga ma-identify sa mga tawo nga kung naay mo tanaw ana nga sa kana nga map nga project, kay ma-identify nila nga mao din ni ang pultahan, mao din ni ang bintana. So mao na siya ang sa cartography.
Good day everyone, I am Zaira Joyce Carbonquillo, a BTLED-HE 2A student, and I am the Group 8 and I am here to report about the enlargement scale. Enlargement, a transformation that increases the size of the shape maintaining its proportion. This transformation scale factors greater than 1 to create similar shapes that are larger than the original. Understanding enlargements is crucial in geometry and has practical applications in fields like architecture, engineering, and graphic design. A scale factor is a number that represents how much larger or smaller a shape becomes after a transformation. In enlargements, the scale factor is always greater than 1. For example, a scale factor of 2 means the new shape is twice as larger as the original, while the scale factor of 3 creates a shape 3 times larger. There's the example number 1. The given is the factor of 4. So, mo na siya. Ang given na siya, ang square nga na ay 2 o 3 cm. So, mo na siya how to enlarge the scale. So first imo na siyang i-times ang 3 sa ubos ug kanang given nga 4, so factor 4. So 4 times 3, 4 8 12, so 12. So mo na siya mag-line ka og up to 12 katason nga centimeter niya. 4 times 2, so mo 8, so mag-line na sad ka mo nang nahimo na siyang larger square. So naray mga other examples diha nga inyong makita. Thank you. That's all for the enlargement scale. Thank you.
Good day everyone, I am Felgen Rosal and our topic is all about scaling. So in my topic, let's tackle about the full size or full scale. A scaling method where the object is withdrawn from its original size or the given size reflected from its detailed drawing to create an equal size drawing of the actual object. Here's our example. Let's remember that the full size or full scale is 1-to-1 drawing. This is an equal or 100% of the original size of the object. So, our example is drawing a 2 cm square on a sketchbook page. Suppose you want to draw a square on your sketchbook page and you want it to be exactly 2 centimeters on each size. In a 1-to-1 scale drawing, you would use a roller to measure and draw a line that is precisely 2 cm long. Using a protractor or set square, you would ensure that the next line you draw is a perfect 90-degree angle and also 2 cm long. You would repeat this process until you've drawn all 4 sides of a square, each being 2 cm long and each corner being perfect right angle or the 90 degrees. The result square on our sketchbook page would be exactly the same size as a physical square with a 2 cm size. So, in this case, the 1-to-1 scale ensures that the drawing of the perfect square accurately represents the intended size or shape on our sketchbook.
To get the measurement of the scale drawing by computation method using common metric unit. So, kaning common metric unit is we have the length, centimeters, meters, millimeters. That is the example of the common metric unit. And also, there is more. But, kanila nga to ang fokusan. Kaya we're going to scale a area. So here are the formulas of the computation scale. So we have the measurement over scale of instruments times 100 equals to the centimeters or unit on your drawing instruments. So good morning everyone. My name is New James Muterde and I am from BTLED-HE 2A. For today's video is we're going to talk about on how to compute a scale. So my topic is basically the computing of scale. So let's start. So in this picture is that the basic formula is that measurement scale times 100 equals the drawing size in meters, where measurement is the actual size of the object in meters, while the scale is that the ratio indicating how much the drawing is reduced. Example, 1/130 means 1 unit on the drawing represents 30 units in reality. These are the steps to solve this picture. We must first identify the actual measurement. We have the lot size is 20 meters times the 30 meters. Second is understanding the scale. The scale is 1:30 ratio. This means 1 meter on the drawing represents 30 meters in reality. So third is we're going to apply the formula. For the 20 meter side equals 20 over 30 times 100 equals 20 over 30 times 100 equals 66.6667 centimeters. For your 30 meter side is that 30 meters over 30 meters times 100 equals 30, which means 100 equals 100 centimeters. So fourth one is interpret the results. The 20 meters side is represented by 66.6667 centimeters on the drawing, while the 30 meters side is represented by 100 centimeters on the drawing. So let's going to break down. Scaling the 20 meter side, you divide the measurement 20 meters by scale factor 30 to find out how many meters this side will be on the scale drawing. 20 over 30 equals 0.6667. Then, convert meters to centimeters by multiplying by 100. 0.6667 times 100 equals 66.6667 centimeters. Scaling the 30 meter side, similarly, divide the actual measurement 30 meters by the scale factor 30 to find the scaled length in meters. So we have 30 over 30 equals 1 meter. Convert meters to centimeters by multiplying by 100. 1 times 100 equals 100 centimeters. So here are the important notes. So units always ensure consistency in units. Convert all measurements to same unit before applying the formula. In case the final answer is desired in centimeters, so you are converting from meters to centimeters in the final step. Scale representation is that scale can be represented in different ways. Example, 1/30 or 1 over 30, or as a statement like 1 centimeter represents 30 meters. Understand what the scale represents in each case. Good morning everyone. My name is New James Mutarde and I am from BTLED-HE 2A. So for today's video, we're going to talk about the definition and the key aspects of computing skills. So in the first video we talk about the solving of the problem given. So in this video we're going to talk about what I said earlier, that we're going to talk about the definitions and the problems, the key aspects rather. So let's start. So computation of skills, it is the computation of skills involves determining the relationship between the dimensions on a drawing, map, or model and the corresponding actual dimensions of the real-world objects or area it represents. This process allows you to accurately represent large objects or spaces in a smaller, manageable format while maintaining proportional accuracy. So, the computing of skills is that ma-involve dira ang real objects, dimensions, o models. Nga naman, because nag-talk sila about unsaon pag compute sa certain area. So by that is by computing a scale is we need to have a book wherein dito nato ibutang ang atuang na scale. Like for example is kanang area is 20 meters. Then atos pikas is 20 meters. So mao to siya ang imo ibutang sa scales. Diba? So by that is it can help you represent a small but maintaining the accuracy of your drawing. Di lang drawing but it may also apply in the real world objects. So let's go to the key aspects of the computing skills. So we have the scale ratio. This is the fundamental expression of the relationship, typically written as a ratio. Example 1 or 100 or 130. It means 1 unit on the drawing represents 100 or 30 units in reality. So like for example is that 130. So ang imong gibutan nito sa usa ka width is 1 unit. So ang katong 1 unit is nag-represent to siya in 30 meters in reality. Gets? So next is we have the formula for scaling down. So by finding scaling down is that we need to have this formula. The drawing size equals the actual size divided by the scale factor. So where next is we have the drawing size. Is the dimension on the drawing. Kaning drawing size is mo ni siya ang dimension of the drawing. So with the help of this is we can predict the certain area. So dili na kay lisod sa ato pag-identify kung unsa na kadak-a nga area by the help of drawing size. Next is the actual size. So ang kaning actual size is the real world dimension. So ang kaning actual size, like for example, is katong 30 meters nga ako ang gi-istorya kaganina. So mo ni ang formula sa scaling up. Finding the actual size. So actual size equals the drawing size times the scale factor. So mo ni siya ang formula sa scaling up. Next, we have the unit consistency. It's crucial to ensure that the units of measurement are consistent when applying these formulas. If the actual size is in meters, you may need to convert it into centimeters or millimeters to match the desired unit for the drawing size. Like for example, kaganina is, diba nato yung 30 meters. So ang katong 30 meters is that you need to convert it into centimeters sa drawing size para ma-match ang dimension sa drawing size sa imong gidrawing. Pero ang actual size jud yato is 30 meters jud. Dili malahi. Ang nalahi lang is dito ra sa drawing nga imong gibuhat. Next is applications. Skill computations are in various fields, including architecture, engineering, cartography, map making, model building, and graphic design. So mo to ang example kung asa magamit ang computing of skills. So in essence, the computation of skills is the mathematical process that ensures accurate and proportional representation of real-world objects or areas in skill formats. So ang computing skills is very important kani siya when computing a certain size, a certain width in a certain area. Na also it can compute the dimensions which may help the architecture build buildings of or by knowing or by computing the scale.